Good day. Today I will be discussing to you the topics that were tackled this final term in ECE321. The first is Laplace transform and electrical circuits. And the second is the transfer function. Under transfer function, we have Z and Laplace transform. The first topic for today is about Laplace transform and electrical circuits. We should know that S is equal to sigma plus j omega, wherein sigma is in the real part and j omega is in the imaginary part. First, we should know the differential equation transform or DE transform, wherein f of t, function of t, wherein which is in time domain, will be transformed to f of s, which is in s or frequency domain. And in the differential form, df of t over dt, this will become s f of s. We only multiply s to the function of s domain. Then, in the integral form, f of t dt, this is equal to fs over s. In this part, we will be dividing f of s to s. Second, we should know also the time and Laplace model. In the time domain, we all know this circuit, v of t, this will become v of s with the same circuit. I of t will become I of s, the same also. Vt is equal to R times I of t. Then, when we transform it to S, V of S is equal to Ri of S. In the inductor, V of t is equal to L di of t over dt. Then when we transform it to S, V of S is equal to SL. We only why? Because this is in the differential form. So, SL times the I of S, which is in the current flowing there, minus Li of 0. Why? Because this is the initial condition. And why negative? Because in the inductor is this is the one which is resisting current, the flow of current. Then in the capacitor, V of t is equal to 1 over c, the integral from negative infinity to t, I of t dt. Then when we transform it, V of s is equal to 1 over s of c times I of s, the current flowing there, plus VCO over s. Why plus? Because the capacitor is a component that charges voltage. We have one example here for the RLC circuit. In this example, we have a voltage source of 20 volts and we have 4 resistors, 5, 10, 7, and 12 ohms. In the inductor, we have a 0.6 Henry and capacitor is 100 microfarad. But how can we solve this? We will be finding initial conditions. I sub LO and letter B is B sub CO. Number 2 is IS. When the switch is closed, the inductor here will become a wire and the capacitor side, and the capacitor, this will become open wire as what you can see here in the circuit diagram. Then we will be solving for IL sub O, which is equal to 20 over 5 plus 10, and it is equal to 20 over 15 I sub LO is equal to 1.33 ampere. The branch here will become open, so there is no current flowing. So we only use Ohm's law, 20 over 5 plus 10, which is equal to 1.33 ampere. For VCO, we will be using there the voltage divider method. V total, which is 20, times the R2, 10 over 5 plus 10, which is equal to VCO is equal to 13.33 volts. From this, we will be having a Laplace model. The 10, 7, and 12 ohm resistors, the inductor will become SL, and in the capacitor 1 over SC. Then the voltage source for the inductor is the LILO, became LILO. Then for the capacitor side, capacitor source, V sub O over S. The second topic for today is about transfer function. In transfer function, we have input entering the system, leaving the system as output. For the time domain, x of t will enter the system, h of t, then leaving the system as y of t. Then on sample domain or n domain, x bracket n will enter the system, then leaving the system as output y bracket n. For the time domain and the n domain, the operation we will be using is the convolution. For x and z domain, x or capital X of s entering the system, h of s, and will leave the system as y of s as output. Then for z domain, x of z entering the system, then leaving the system as y bracket z. The operation that we'll be using is the multiplication. We have examples for transfer function. Find h bracket z. We have here the block diagram for that. H bracket z will enter these two systems and will directly going to y bracket z. Here is our solution. Y bracket z is equal to x bracket z, then plus z to the negative 1 times z to the negative 2, which is z to the negative 3 x of z. Then we will simplify that equation as 1 plus z to the negative 3 x of z. Then to find h bracket z, which is equal to y bracket z over x of bracket z, then it is equal to 1 plus z to the negative 3. Another example for the S domain. Find h of s. The block diagram here is x of s pointing to the positive, then going to h1s, going to y of s. Then from y of s, going to h2s system, then going again to the positive. So, the solution here is y of s is equal to h1 of s, which is there, times xs, which is here, plus y of s, h2 of s. Then, substitute or distribute those elements or those in the equation. Xs times h1 of s is xs h1s plus ys distributed to this is ys times h1s, then also this times h2 of s. Then transpose this y of s here in this side. Ys minus ys h1s h2s equal to xs h1s. Then we will simplify this side, and it will become 1 minus h1s h2s y of s equals to xs h1s. And to find hs, which is equal to ys over xs, the input side here, which is h1s, will become our numerator, and and for the denominator, we will be getting the output side, or in the y of s. This is the shortcut for finding h of s. For our last example, find h bracket c. We have here the convolution operation. X bracket n convoluted to h bracket n is equal to y bracket n. But how can we do this? We'll be having this form of equation. X sub 1 is 3 times 1 is 3, 2 times 1 is 2. And for x sub 2, we will shift here on this place, because we will be multiplying 3 times 2, 6, and 2 times 2 is equal to 4. Then we will be getting the sum, 4, 2 plus 6 is 8, bring down 3, the y sub n, or y bracket n, is equal to 3, 8, 4. To convert this to y of c, or y bracket c, this is equal to 3 z sub 0, or simply 3, plus 8 z to the negative 1 plus 4 z to the negative 2. And x bracket c, which is here, is 3 z sub 0 plus 2 z to the negative 1. Then this will become our output side, and the x of c will become our input side. And to get h bracket c, we will be having 3 plus 2c to the negative 1, which is our input side, and became our numerator. And for the denominator, we have the output side, y of c, 3c sub 0, or 3c to the 0, or simply 3, plus 8c to the negative 1 plus 4c to the negative 2. For a more simplified answer, we will be multiplying this equation to the largest degree, which is 2. So times c to the 2, or c square over c square. Then this will become 3c square plus 2c over 3c square plus 8c plus 4. Then after that, we will be using long division here. So 3c square plus 2c divided by 3c square plus 8c plus 4. Then the first term, we will be dividing the first term. 3c square over 3c square is equal to 1, times this again. This expression will become 3c square plus 8c plus 4, negative. So 0 minus 6c minus 4. Then divide again to this equation, then, or expression, negative 6c divided by 3c square will become minus 2c to the negative 1. Then multiply again to this, and will become negative 6c minus 16 minus 4c to the negative 1. And don't forget, we have our operation is subtraction, so put negative. Then negative 6c plus 6, 0, plus 12, minus plus 4z to the negative 1. Then, again, divide this to this. Then we have 4z to the negative 2. Multiply again. As you can see, or as you notice, we are only repeating the, well, we are only repeating the process in dividing. When this happens, this is called the step function. That's all po. Thank you and goodbye.